I've been working on this device, this monster here in front of me. You can't really see it, but it is a foosball table. And so what I've done to it is I've used different components by Adafruit to kind of like build a digital scoring system. So start off here. This is what you're going to be seeing here in the photo. There are two game modes. There's classic, and which is like first to 10 or first to whatever score you want to go first to. And then also timed halves. So you can set a time per half and see who wins. You can customize parameters. So for example, in the timed halves, there's a lot of different customization for parameters. So for example, if you're playing somebody who's not that great, then you can set a score ratio so that when I score 3 goals, I get 1 goal. And I'll kind of demonstrate that a little later on. There's audio, and hopefully we can capture that via my lav mic. But then, yeah, so it also runs strictly on Python, CircuitPython to be exact. I'm not exactly sure. I'm kind of new to CircuitPython. I think the only difference is the way that they create their libraries. I'm not exactly sure, but like when you look at the code, it is just like striking image of Python, and it operates exactly the same. So what I used in this project are is a microcontroller, pressure-sensitive resistors, buttons, an LED matrix, some speakers. What else? A breadboard, of course. And so I'll walk you through all of these components that I've used. So the microcontroller I use is the Adafruit Metro M4, the Grand Central. The reason I chose this one after a lot of different testing is because of the processing capacity. I did buy the Metro M0, and you could only write 250 lines of code, which is good, but limiting, especially on a big project for this. But yeah, I think Daniel challenges you to write as few lines of code as possible. So, you know, you could try it out. But the features of this, you have, I think 53, yeah, it looks like 53, I guess those are digital pinouts. And then I believe you have 16 analog pinouts. You have a micro SD input, reset button, obviously. You've got different, you know, you've got a 5-volt out, you got grounds. I can't remember all the specifics, but in the README for this project, you can find everything and all the good stuff. So check it out on Adafruit, Metro M4 Grand Central. And then onto the sensors. So these are pressure sensitive resistors, also touch sensors. There's a cool site, I think it's on that FSR 406. It's www.iefsr.com. You can find these there, or you can find them through Adafruit's site. These are found on Adafruit's site, at least these photos were. So you've got the 406 FSR. That is a little like 2x2 touchpad that I put on the bottom of the goals, and then also the bottom of the ball retrieve, which I'll show you here in a little bit. And for the 408, I kind of lined the back of the goal, which also I'll show you here in a little bit. And then onto the LED matrix, which I call the miniature Jumbotron. Um, it is what it is, 32 by 64 LED, programmable with that is one thing I forgot about this. You have to use a LED matrix. Oh man, what is it called? I'll look it up later. I think I can find um, the component, but yeah, what it does is it translates the code from the microcontroller to the LED. So it's just a little like uh, almost circuit board type component. Um, so the buttons I used for the control panel are just momentary buttons. Red, yellow, green. They're good colors to tell you what to do and what not to do. And then an increase and decrease button. Arcade LED buttons I'm using on the sides for each player to kind of commence, gameplay and pause the game when you're playing in timed halves mode. Let's see, the breadboard itself, this is just a mid-sized breadboard. If anybody is familiar with it, you've got, terminals, positive and ground terminals on both sides. I believe you have 60 total pinouts, or at least, inputs and outputs. So let's see. Then miscellaneous, we have the dot star or NeoPixel LED strip. I'll have to admit that's coming in the 2.0 version of this table. It's kind of an extra feature that I've installed in the goals. So when you turn it on, goals light up. When you score a goal, it turns green. So very, very simple stuff. Speakers I found on Amazon. This little kit that you build your own speakers that you can use for computer, really anything. I just used the speaker cones actually, or the drivers. I didn't really use the extra components in there, like I think that's an amplifier, those red circuit boards. And then I used a Class D amplifier from Adafruit to power those speakers. Let's see. All right, on to the overview of the project. So again, this has taken me about 3 months, maybe a little more, I'll be honest. I can't remember what day I started or month, but it was kind of a rigorous process because it was just me. So I had to do a little bit of everything. And before I started building the housing component, always, always, always test things before you start installing, because you could install and nothing works, obviously, and then you're stuck trying to troubleshoot, pulling cables. And I luckily didn't do that. I had the foresight to test it out. But this is my little station I kind of came up with. You got the little home, away, goal pads down there, the start stop button, LED buttons, and then of course the screen, and everything going from the breadboard into the microcontroller itself. So the housing unit that I built out of plywood, I have a little bit of experience working with carpentry, but this is the best I could come up with. These little, if you notice the little holes kind of on the corner of where the screen goes, there's little magnets that sit in there, so you can easily like pull out the screen and get access to all the components inside. The wiring itself was it's a little messy back there, but before you install everything, make sure, everything is going to fit pretty much. I think I probably could have made this a little bit bigger. But here you see the buttons installed, speakers running to the breadboard. That little breadboard amplifier is what is going to be ran to the microcontroller, and then that little brown thing at the back of the housing is the potentiometer, fancy word for a volume knob, right? So this is what it looks like installed. It's an electrical engineer's nightmare, and probably anybody's nightmare unless you like detangling things. But yeah, so there it is. The Adafruit RGB matrix shield is what you need to run your RGB matrix, the miniature jumbotron, if you will. But yeah, fitting all that stuff in there, probably could have done something differently, but it is what it is. So installation, let's jump to the goals here. So you can see in the back there, those are the 408s. And these resistors can be cut to length. So they come in different lengths, from I think 50 millimeters to maybe 500, 600 millimeters. I'm not exactly sure. And then you see at the top there, the LED strip that is non-functional at the moment. I apologize. Stick around for 2.0. But preparing these goals was a little tricky. You have to almost take apart the whole foosball table, take these goals out, kind of custom fit, make different cuts or drill holes to run wires. But as you see in the picture on the left, the two 408s, there's actually a third 408 on the back of the board. I guess the inner workings of the foosball table itself. And then you have the 406s at the bottom of the goal with the tube coming out there. So installed, let's see. Oh, and the ball retrieval. So this is the LED button that is on each side of the foosball table that each player would press in order to kind of commence, gameplay. And the 406 is in there as kind of like the ball retrieval. As the ball hits that sensor, for example, in the timed halves mode, the clock starts back up. If it doesn't sense that, the backup would be just hitting the button to restart the clock. And these indicators, these LEDs have LEDs in them. So if for some reason the sensor doesn't pick up that the ball has returned, then the LED will stay lit until you press it. So the table itself had to flip it upside down, and this is all, kind of, I'm not going to show you what it looks like now because there are a lot of wires, and it's kind of the same thing, kind of the same mess as the housing unit itself. And so, yeah, installing the housing unit was very interesting. You had to run wires through. As you can see, the pipe there is what I'm running all the cables through to get to all these sensors and buttons and lights. But yeah, in hindsight, I probably should have used PVC due to this is galvanized metal. So when you do that, there's sharp edges that could cut wires, even though I don't think it cut any of the wires, but you never know. I think maybe that's why the LEDs aren't working, but I'm not exactly sure. But yeah, so on to the different game modes. So we've got classic and timed halves. Classic is your first to 10 or whatever, whatever you want to set the high score to. And you also have a best of parameter that you can edit with the buttons. It's kind of a bad lighting picture, but so the two numbers at the top is what indicates the best of. So for example, you have a best of 3 series. If the away team or player 2, as I would call it, if they would win the first game, the blue number at the top right would increase by 1. So best of 3, it's, first person who wins 2 games. And then we've got the timed halves. So this works kind of like an actual soccer game where you have 2 halves, and you can also do a legs version where you play the first leg and the second leg of like I don't know, a tournament style knockout round series. And it, I've set it up, and this is kind of the most complicating part of the project, was determining who is scoring on which side, and you have to switch sides. So it's kind of hard to explain. I can't remember how I did it, but I did it. So anyways, yeah, you can edit you edit the time there. You can increment, decrement by, I think, 15 seconds. And then the blue numbers in this scenario indicate the total amount of goals scored. So, for example, you're on the leg 2. The away score and the home score will be 0, but your total score from the first game will be displayed at the top. So you can kind of keep track of, how many goals you have to score in order to beat your opponent if you're down. So yeah, I think that is about it with at least the presentation slideshow portion of it.